And so we gone through these features or distinguishing facets of complicated and complex contexts or problems or systems. And one thing to notice is that in general, there are very good reasons to think that uh, due to growing interconnectedness in our world, the contexts have been more and more shifting from simple or complicated ones to complex ones. And if we keep on using the solutions and the ways that we have been using in the complicated domains, then it might not really work as well as we would want. And so some people have suggested that big data would solve all of this for us. Maybe lately there have been new suggestions from large language models. But the thing is that the more there are variables at play, the more spurious correlations you'll see. And this is as we spoke about in the when we talked about the uh, heuristics. Uh, uh, we might have mentioned this, the Google flu trend, where they used a vast amount of data to come up with predictions for the spread of influenza epidemics. And this turned out to just suddenly work not very well. And whereas using just a single variable, the most important variable in this problem, was really a better predictor than the big data algorithm. And there are two papers that in the bottom of the screen that I suggest if you want to learn more about these sort of fundamental limits of what we can achieve. So just to give an indication of this, let's think of the theoretical domains framework. So this is a framework that experts from different areas have developed to come up with this, like all the influences on behaviors and how we can categorize them under one framework. So we have knowledge and emotions and social influences and environmental context and resources and so forth. And there are 14 factors. And so if our problem is one that is component dominant, then what we need to do and what we can do is look at these 14 facets of the problem separately and solve for each, and then come up and get to the right, like fix the problem in that way. So 14 is not that big of a deal. But then when we think of how many links there are, so if it doesn't really matter that much whether a person sets goals, but if it actually matters whether those goals are connected to one's social influences. So if they get like really detrimental goals from social media, like drinking as much as you can, or some sort of these things. Many who are adults now remember from their own youth. So it's not that simple anymore. So you have to take into account these linkages, and there are actually with 14 factors, there are 91 potential links if they are only if you don't count whether it's A to B, but it could be from A to B or B to A. And this is a bit more, but it should still work if the system was stable. But the problem that we face is that if what actually matters is not whether goals and social influences are connected or not, but the whole the interaction pattern of these things. So if knowledge is connected to skills and skills are connected to social identity, uh, but intentions are not connected to goals, and whereas emotions and behavioral regulation are connected in this context. And if that is what matters, like what are all the links that the pattern that the links form, then we get into a bit more difficult terrain. So I want you to spend just 10 seconds now to think about how many different patterns can you find are there with these 14 different um, um, factors. And one of those patterns you actually see on the screen. Okay, so I hope you came up with some answer or a clue what you thought would be the right ballpark. The right answer is about 2.5 octillion. So this, if we round it into three, that would be a tree followed by 27 zeros. And we have one of those patterns that you can see on the screen. Here's another one that's a bit more dense, and these different types of patterns can really, there can be a lot of them. And this requires not trying to understand them all. It requires some simplification. It requires us to have some sort of a map, some sort of maybe an evolutionary design where we try things out and figure out what works. So we can't just think about, okay, so we change social influences and that will change the environmental context, which will change intentions, which will change skills. No, that doesn't work anymore. It's out of the window. Now we need to go and try different things, see what works, feed those things that work, uh, and dampen those things that don't work. And one thing that we can do is to do this is to work in teams. So we have these complex problems where, like on the point A on the left, it shows like a very like a traditional way of working. So you have the black ball is a person who has a team of experts in their disposal. So each of these balls is one expert. The blue expert can, let's say they can all solve 10,000 problems. The blue of their own domain. So blue expert can solve 10,000, yellow can solve 10,000, and so forth. And when the black manager gets a problem, they see that, okay, so this problem would be best fit for the green expert, and they divert that to the green expert, and then they get another problem. Oh, this goes to the yellow, and so forth. And if all of these experts can solve 10,000 problems, then you can solve 50,000 problems in total. So 10,000 plus 10,000 and so forth. And solving 50,000 different problems is not really a very satisfactory situation if you can, if you need to solve 23 octillion potential problems. But when you put these five people, and there are only five, and people can usually solve more than 10,000 problems if they really are experts in a field. So if you put these people working in a network so that they each have to contribute to the solution of a problem, and importantly, they also can work together, and there is not like one dominant person, and so that everyone just says yes to what that person says. But in the ideal case where you can have these people work together, and we have a lot of ways to do this in social psychology, for example. Um, they can actually solve 10,000 times 10,000 times 10,000 times 10,000 times 10,000 problems. So that is the 10,000 to the power of 5 instead of 10,000 times 5. And 10,000 to the power of 5 results into a number that is 1 with 20 zeros following with that. And that is quite a large increase compared to the setting that we had on the left. And of course, these need to be, these ways of working need to be put in the right context. So when we are in a complicated context, we can do this at very efficient working. So we direct the problems to whoever can solve them, and then that person solves the problem. And that's very efficient, and it's the right thing to do when you're dealing with a complicated context. But in a complex context, you need a different way of working.